no, like, I thought it was due Friday.
Which one?
The naming ionic compounds.
Oh, the first one?
Yeah, I thought it was due Friday.
Yeah, it's all right. I thought it was
I'll
due.
send it to you. I'll send it to you tonight or like
What?
after this.
I thought it was. What? Just told your horses.
So it was due like last night.
Oh, okay. That's all right. It's. There's only been. Oh, wow. I didn't have a whole lot of time to look at that sort of stuff this morning, so there's all sorts of them. Yeah, I will. That's no big deal. It's all good.
All right, sounds good.
Um, it's. I'd rather things be finished. Oh, so today's Wednesday. Uh, where did
Yeah,
everybody?
I'm gonna send mine in, but I have no idea if it's right or not. So
Well, that's the whole. I basically I will go through and tell you which ones are. If if I there's 12 of them, so if I only make comments or feedback about 4, 8, and 9, the rest of them are okay. And I've just been putting letting people know which ones had issues and whatnot. It's stupid window. I should try to find something to cover it with. Uh, did more people show up? I think I'm recording. Oh, it's over here. Yeah. Oh, I better do that. So the third assignment, which is basically my old part of my naming test without multiple choice, is up there. I can't remember when it's quote unquote due. Naming everything May 8th, which is next week, next Friday. Um, I didn't mean to click that. So if you have questions, you can post them up on the thinger or whatnot. Friday, Tuesday, we kind of did my kind of strategy for a mixture. If it's writing a name acid, then ionic based on group, and then molecular because that's what's left over, and those need prefixes. Writing formulas is actually the easier one because there's more kind of clues. If it's got a prefix, it's molecular. Just go by numbers. If it says acid in the name, it's an acid. So use those rules. And then you have to go through with the ionic compound. I'm pretty sure I may have changed how I, apparently last year I did acids, then moleculars, but 6 1/2 dozen the other. But in the file, there is all of the, hopefully most of them are correct for practice 6 or 7 and 8. Um, if you have any questions, oh, the very last one on practice 8, H2O, the accepted name in terms of chemistry for H2O is water. So don't overthink things. It technically you could put dihydrogen monoxide, you can put all sorts of things, but it's water. Um, yeah, if there's some polyatomic ions that aren't on your table, I wouldn't be super worried. I don't think I put any of them in the assignment that weren't on your table. Uh, but if there's no questions, well, that's naming. Naming is something, it's a fundamental skill. We probably took a little longer than we could have but technically in class, because we would have started it a week and a half ago. Like calendar days, I don't think I spent any more time than I would have. Sorry, just a little thirsty. Need more coffee. Kids are exhausting. And Brittany started something new with WorkSafe, so it means she has to work more. So, chapter 10, 11, and I want to say 12 are fairly linked. Let me just double check. Of course, this one ends there. 9 is naming. 10 is a unit called the mole. Yep. 11 is or 11 is equations, and 12 is a thing that ties everything together called stoichiometry, which fundamentally can involve any of those four things. So that's something that I didn't put in the notes. It's a silly story. So the mole is a chemical unit. It's not a measured thing, it's a counting thing. A dozen is 12. A grand is 1,000. Oh, Lord. And apparently I forgot. Now a gross is, I think it's a dozen. But okay, yeah, that was a really bad thing to search. Oh, yeah, 144. That's a gross is a dozen dozens, which is 144. These are things that we count. You go to Tim Hortons and ask for a dozen donuts. People know what you want. If not that any of you would go to a bank and say, I need $6,000. Well, some of you might. I was going to use some sort of drug dealer reference, but it's like, no, none of you do drugs or want to do drugs. I hope so. But if you go to a bank and ask for $6,000, they know what you. I assume none of you. Let's see who's on here. I don't know. I don't think any of you do drugs. Don't do drugs. They're bad for your brain. Um, a ream. A ream is an actual unit. If you we're at school, I could go show you a ream because paper is sold by like a package of paper is technically a ream of paper is 500 things. So in chemistry, we have this unit called the mole, and it is 602.214.141.070.409.084.099.072 things. But in chemistry, it's atoms or molecules. And we have to use moles for a whole bunch of things because when we talk about a reaction, if I pick a simple reaction in forming water, hydrogen and oxygen, based on the periodic table, have vastly different masses. Every hydrogen atom weighs 1. Every oxygen weighs 16. So because we can't just say a gram of this and 16 grams of that. Or if I take 10 grams of each and assume it's going to make everything nice and even, because everything has different mass, we have to use the concept of a mole. And it's named after this Italian guy who did um, properties of gases. Uh, we, so you've seen it. Like that's the actual number. It's 6.02 times 10 to the 23rd. Sometimes you'll see 6.022. It's ridiculously large. Like that's well, there's 84 million. There's 9 billion. There's 70 trillion. Like I just saw today, the federal government's projected budget deficit this year is on the order of $250 billion. Well, that's 250 instead of 409. Well, we've got 3, 6, 9, 12 orders of magnitude larger. So it's like the concept is applicable. It's a fancy dozen. It's just a ginormous dozen. So we're gonna do some calculations. We can do. I'm just gonna skip through some of these things. Um, we're gonna look at a couple of them. We could see if you spent money at a rate of $1 billion a second, how long would a mole of dollars last you? And it's an astronomical amount of time. A mole fundamentally is defined as the number of carbon atoms in 12 grams of carbon 12. And carbon 12 has come up a whole bunch. Our atomic masses are all assuming carbon 12 weighs exactly 12. So everything in this, it's the science of chemistry and calculation is based on that assumption. And it's just because, so it's standardized. So everything is all the same. A mole is 6.02 times 10 to the 23rd particles. So whether it's carbon atoms, iron atoms, it's all the same number of things. Representative particles, we have molecules. We use formula units because we've said a whole bunch. A crystal of salt is billions of carbon or sodium and chloride ions in each of the three-dimensional directions, but there's one of each. So we simplify it down to the same idea like a molecule, like water is H2O. Everything is exactly one oxygen, two hydrogens. Salt is kind of different, but it's kind of similar. Diatomic, we've got to worry about those. We're doing conversion factors. And if you've taken physics last semester or now, you've done conversions from moles to, well, you haven't done moles, but meters to kilometers and all of that sort of stuff. And we use a similar kind of setup. How many seconds old are you? You guys are all mainly, let's say, 16 years, give or take. I know I don't know exactly. I don't care exactly. If we want to know how many seconds old you are, well, does anyone know how many seconds there are in a year off the top of their head? My guess is no, because I don't even know. I know we know how many seconds there are in a minute. We know how many minutes there are in an hour, and we're converting. So if I want to take 16 years and make it to seconds, I'm going to do all sorts of multiplication. Well, I want to get rid of years. Well, we know there's roughly 365 days in 1 year. That's a conversion factor. In terms of math, units, years, and years cancel. So if I multiply that out, because this is multiply on top, and then we'll divide by something on the bottom, that would tell us how many days there are in 300 or in 16 years. Well, but the question doesn't ask, it asks for seconds. Okay, so I want to get rid of days. Well, what do we know days are broken down into? One day is 24 hours. So if we, again, the units cancel. If we multiply that out, that would be how many hours old you are. But again, it doesn't ask for hours. So we want to get rid of hours. In 1 hour, there are 60 minutes. And again, we don't want minutes, so we're going to put it, whoops, on the bottom. 1 minute, there are 60 seconds. So all of the units cancel out except for the one that we want. And normally, whatever unit we want is at the very end. And now, different teachers do this different ways. Personally, I will go through and do each calculation as they come because that's how I learned how to do it a long time ago. Apparently, Mrs. Parley does all the multiplication and then all the division because multiply and divide are, sorry, I'm just not, are fundamentally the same thing. Um, it actually doesn't matter. I've never checked with Mr. Gons. I can't remember what he does, but we just need a handy dandy. Whoa, I do not want the maximized Windows calculator. I just want to put it over here. 16 times 365 times 24 times 60 times 60. So if you were born right now, 16 years ago, you would be 504,576,000 seconds old. And that's a really big number. 3, 6, 7, 8, 5.0576 times 10 to the 8th seconds. If we were going to do a whole bunch of stuff with actual atoms and whatnot, we would do a bit more scientific notation. In this chapter, we're probably going to be looking at like two-step calculations because we don't have the time to do everything. So we could, how many basketballs can be carried by 3 trucks? I think either part of the question is missing. Yeah, there's something missing there. How many basketballs can be carried by 8 buses if 3 cars? And there's a whole bunch of stuff. Sorry, that's bothering me. I thought I had that off. You could do conversions. How many horses can be exchanged for 500 chickens? Um, well, 500 chickens is 1 pig. Chickens, 10 pigs is 1 cow. You don't want cows, 2 cows, 4. And chickens, pigs, cows. Cows cancel out. We have horses. Whatever, that will work out to something. How I would do it, 500 divided by 25 times 1, I don't do that, divided by 10 times 3 divided by 2. So if you had 500 chickens, you can trade it for however many, 3 horses. We normally would do how many, like finding molecules. How many molecules of carbon dioxide are there in 4.56 moles? Well, that color doesn't stick out. 4.56 moles of carbon dioxide. 1 mole of CO2 contains oh, I got that backwards, sorry. We have moles, we want to get rid of moles. Each mole has and I can multiply that out. This time I need a scientific calculator because I need the exponential part. 4.8 56 times 6.02 exponent, and this is where we would get into fights with calculators. That gives us 2.7. Where'd my pen go? 3, 6, 9, 12, 15, 18, 21, 24, 2.74, 2.7 times 10 to the 24, 2. And we can convert back and forth and all of that. It's useful conceptually, but it's not something that you use on a regular basis, even in a chemistry degree, unless you're doing very specific things. So I want to skip to, like, if we were in school, well, there'd be a day and we'd be done. Measuring moles. We can't measure moles because you can't see an atom. You can't just take tweezers and count. You can't do what they do at Tim Hortons and, well, they've got, you go pick Timbits or whatever, because you'd be doing it forever because it's just an insane quantity. So our mass on our periodic table, oh, come on, fingers. Is that going to open? There we go. We've talked about this mass that's on our periodic table as atomic mass units based on carbon-12. But we're also going to talk about it as what's called an atomic mass. How much, and if we, looked at that unit, it says G/M. It's how many grams of that 1 mole of those things would weigh. So basically, we've taken that atomic mass because everything in terms of a mole, whether it's hydrogen or iron or whatever, well, if we go from one thing to 6.02 times 10 to the 23rd, yada, 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 things, it's proportional. So it all works out. Was 1/12. I do not know how to spell 12th. It sounds 12th. 12th? I don't know. 1/12. Since the mole is the number of atoms in decimal in the periodic table. Not sure what that word. Or, well, we call it molar mass. Mass of the average. Why does it seem to me that there's stuff missing there? Since the mole is the number of atoms in, 12 grams of carbon-12, the decimal is the mass of 1 mole of carbon-12. The average mass, atoms in AMU, or the mass of 1 mole in. We can build scales that measure mass in grams. That's what scales are for. Now that I think about it, there's 5 or 6 of them sitting locked in my desk at school. A scale measures grams because it's mass. It's how much something is pulled by, or how much matter is there. So we know this relationship, and we can use, well, that relationship to figure out how much of something is there. So we use atomic mass to scale up to tell us how much of something is there. 1 mole of, or the gram atomic mass, or the atomic mass on your periodic table, is the mass of 1 mole of something in grams. Carbon, if we have a mole of carbon, we have 12.01 grams of it because of the isotopic distribution. Hydrogen is 1.01. Iron is 55.85. Fluorine is 19. So effectively what we do, we count things by weighing them, or taking the mass, technically, if you really want to get. How much would 2.34 moles of carbon weigh? Well, if we take the highlighter out, 2.34 moles of carbon. Well, I don't want to know moles of carbon, so I put it on the bottom. How much does it weigh is grams of carbon. Well, I know 1 mole of carbon weighs 12.01 grams. Moles of carbon cancel with moles of carbon. I can multiply that out. So if you have 2.34 moles of carbon, you have 28.1 grams of carbon. And I'm going to have to worry about significant digits or significant figures, which I'm going to have to find the file and post it up there. Multiplying, it's fairly simple. There's 3 significant figures here. I learned figures. There's 4 there, so I need 3 numbers there. We'll talk about that. I can't be super picky on them right now because, well, I'm not actually marking things. How many moles of magnesium are there in 4.61 grams of magnesium? Well, I've got 4.61 grams of magnesium. How many moles? That means I want moles at the end. And I put that way over there because it doesn't really matter. We're given grams. Grams goes on the bottom. What we want, and chemists, even though moles is only 5 letters, we'll see it up here, MOL. The abbreviation for moles is MOL. Grams is G, and all of that. Well, 1 mole, I know, weighs 24.31 grams. That cancels with that. We're left with the right unit. We're going to take 4.61 and divide by. So that's going to give us 0.190 moles of magnesium. Does this seem somewhat reasonable?
It's high.
So the first, well, where we would do stuff, if I convert a gram of lithium. Oh, apparently that is not blue anymore. Well, I don't want grams. Your first step for any chemical calculation is normally converting something to moles. 6.94. But this is atoms, so I don't want moles. I want 1 mole is, and we can divide and multiply that out. But I'm not going to give you any questions on that. We're going to have questions. Apparently, at some point I did that. Oh, here we go. There's 4 questions. I think those are in the pages that I posted. Oh, scheisse. Doesn't matter because those are atoms. How many atoms? So those are gone. Well, some of you, how many moles? Cross off that. Moles. 10 moles. So I'm just switching those. The first two are identical to that question, I think. Oh, no, the second one. Grams, so it's the same thing. You just have to use the right element. The next two are like that. Just use the same element. I don't want to, like, if we start the next thing, well, this is another 15 or 20 minutes. So I will, well, I don't want to,
No, I mean, so you skip one.
well, no, it's just to stop here. That, like, I'm not, like, we need to know how to do molar mass of a compound because 90% of what is you're going to deal with in chemistry is compounds. But instead of trying to, like, I tried to squeeze things, we're going to convert grams to moles and moles to grams for compounds. We'll talk about gases quickly. There is a whole bunch of other stuff that I might post all of that, but we may come back to it because it's May. Like, we have 6 weeks left. So I want to get to the important things and if we have to come back. So if you could try those, follow the kind of pattern that's there. Um, Tomorrow I'll put answers up and go through them, and then we'll talk about molar mass of compounds, and depending on how quickly we go, talk about moles of compounds. But that's, I think, where I'll stop today because we talked a little bit about that. Is that all right? Oh, I thought that's,
That's good.
I thought somebody, it looked like somebody was leaving. It's a nice afternoon. I'm sure some of you want to go fishing or something weird like that. Oh, it was Ryan that must have left. So after we get through all of this stuff, there'll probably be some questions posted to answer so I can check to see, okay, so and so did this, that, or the other thing. But that is where we shall stop today, unless anyone has any pressing questions. Someone?
What's wrong with fishing?
Nothing. I don't enjoy. I just don't enjoy it. I tried to fish once with my dad. My dad took my brother and I fishing once when we were little. Oh, I'm good. I have no real desire to do it. Um, it poured rain all day. It was cold, and we didn't catch anything. So that kind of was my.
Yes, we went and we hiked for like 4 hours catching.
Oh dear.
It was awful.
Uh, yeah, that's why it's. I mean, it's risk reward. You're outside. You got fresh air. You got exercise. So it's like there's. It's not a bad thing to do. It's just if I'm going to spend 4 hours outside, I'd rather chase a little white ball that I've hit into the woods a few times. But that's just me. Not that I can do that anymore because kids, as I hear one of them running around upstairs. So I will sign off. Give those a shot. If you have questions about either of the naming things, let me know. Um, And we'll see you guys tomorrow.
Thank you.
You're welcome. See you later.
Bye.
Bye.